In this module, you will learn how to create histograms in Excel. After you complete this module, you will be able to create histograms in Excel and describe unique characteristics of Excel histograms. The contents of this module assume that you are familiar with the Microsoft Excel 2013 interface, know how to get help in Excel 2013, are familiar with descriptive statistics on a conceptual level, and know how to create and format charts in Excel. Before we create histograms in Excel, let's review some concepts. A histogram is a type of chart that uses vertical columns to show the distribution of data. The histogram here shows the distribution of kilograms of landfilled waste from a manufacturing facility over 40 days. The values along the x-axis represent the kilograms of waste, and the values along the y-axis represent the frequency of each measurement. We call the columns of the histogram bins. The histogram shown here was created in Excel. A key point to remember about Excel histograms is that the numbers on the x-axis refer to the upper limit of each bin, not the bin center point. For example, the first bin in this histogram begins at 3, which is the minimum value in the dataset, and ends at 5. Before you create a histogram, it is always a good idea to calculate descriptive statistics for the dataset. This includes the mean, median, mode, variance, and standard deviation. Calculating and reviewing these values before creating a histogram can help you interpret the data and also help you verify that your histogram has been created properly. Before you create a histogram, you must first determine how many bins the histogram will have. A good rule to follow to determine the initial bin size is to take the square root of the number of data points, rounded to the nearest whole number. This won't work in all situations, but it does provide a good starting point. Once you have determined the number of bins, you need to determine the width of each bin by dividing the range of the data by the number of bins and rounding it to a whole number. In just a moment, we will look at an example that illustrates these calculations. The easiest way to create a histogram in Excel is to use the Data Analysis Toolpack. By default, this is an inactive plugin for Excel that must be activated. To activate this plugin, navigate to File, Options, and select the Add-ins tab from the menu. If the Data Analysis Toolpack has already been enabled on your machine, it will appear under the heading Active Application Add-ins, and nothing else will need to be completed. Otherwise, the Toolpack will appear under the heading Inactive Application Add-ins and must be enabled. In the drop-down box at the bottom of the dialog box, select Excel Add-ins and click Go. In the prompt that appears, select the checkbox next to Data Analysis Toolpack and click OK. If more than one Data Analysis Toolpack is available, select the one that does not include VBA at the end of the name. The Excel Data Analysis Toolpack is not available for Mac computers. To develop histograms, you can use Excel on a computer in the iTap Labs. Another option is to manually create histograms on your Mac. Now let's create a histogram in Excel. In this example, we will create a histogram that shows the distribution of kilograms of landfilled waste from a manufacturing facility over 40 days. The dataset we will use is shown here. In this example, the data is preloaded into Excel as shown here. We have also already calculated descriptive statistics for the data using the Excel built-in formulas. At this point, you should review the descriptive statistics so you know what to expect when creating a histogram. Next, we use the Data Analysis Toolpack to create a default histogram. To do this, click Data, and then Data Analysis. Select Histogram. Select the input range, which in our case is the 40 data points. Select the output range and chart output. We can now see the histogram that Excel has created. Excel has also provided a table listing the values of the bin upper edges and the frequency within each bin. The bin values Excel has returned do not logically divide the data, so let's try the example again and specify our own bin values. We begin by using the calculations you saw earlier to determine the number of bins and the bin width. Notice that we round these to the nearest whole number. Next, we create a table of the bin upper limits. To determine the first bin upper limit, we add the minimum value of our dataset to the bin width. We complete the table by adding each bin upper limit to the bin width. Now that we have a table of bin upper limits, we can create the histogram. As before, we select Data and then Data Analysis. We then select the input range, the 40 data points. We specify our list of calculated bin upper limits as the bin range. We can now see the histogram that Excel has created. Notice that the bin values in this histogram are more logical and make the data analysis easier. Remember that these bin labels represent the upper edges of the bins. Also, notice that Excel has added one additional bin labeled More. This is a default in Excel and is intended to account for any values above the final bin. Now that we have created our histogram, it needs to be formatted for technical presentation. To format our histogram, we delete the legend, add a title, and change the x-axis label to a descriptive term. Notice that the label on the y-axis reads frequency, so we do not need to change this. Now that you have completed this module, you should be able to create histograms in Excel and list unique characteristics of Excel histograms. If you would like to practice creating histograms with the dataset used in this module, click the Download button. Click the Continue button to continue with this module. This module covers only some of the concepts on this topic. For additional information, refer to other available sources. Also, remember that you can view this module at any time and as many times as you desire.